So this is section 3 of angles. In section 2, just has some problem with the system, so we are just continuing with section 3. We are just making this as part 3 of the part 2 section, right? So let's continue with the question that we were solving in the part 3. You can also watch the part 2 in the description section. I've given a link there. You can also watch the part 2 of this. Just a continuation of the part 2 section. Okay. So let's continue with it. So here, we're able to say that here is 140 degrees and here is what? Angles in a straight line or supplementary angles will be 180 degrees, right? So with this, I'm using the get it to 40 degrees. So we said that if here is 40, I can have a Z shape which is parallel to this parallel lines M and N and what? Here and what? F. So I was having a parallel line from here. So here was for here. So that's what I've made indications here about information you have just done. That angle CBT is equal to angle B. CBT is equal to B, BT, and what? M is 40. We said that was alternate angles. Same also happened to here, which is supplementary angles. Angle is 2 had what? 40 degrees. And we had the alternate section for that. There was what? Alternate angle. Alt angles. Okay. Right, so therefore we can say that replace angle y, therefore y plus 40 degrees plus 40 degrees is equal to what? 360. That's angles at a point. Angles at a point. So I can say that therefore y is equal to 360 degrees minus 40 plus 40 gives what? 80. So here is positive on my left hand. So once it joins, the 360 becomes what? Negative. Guess what? So then I can say that y is equal to, when you take 80 from 360, you will left with what? 280 degrees for y. So the reference angle y is what? 8. So y here for 280 degrees. So that is how we just solve questions on parallel lines. So you have more questions there. We'll be creating another section where we'll be solving more questions on these. But for now, we're just exposing to the concept and truth that we need to know, so that we also create another section where we discuss more questions on this topic that we are just on it. After that, we just do Q&A questions on that. Then you know how to do that. So that is that for that. So let's continue. We are moving on to another section. So we take on to the next session, which is types and properties of triangles, as we define in our first video with the learning outcomes. We are just moving on. We are just a little bit get to the end of this section, then we discuss more questions. So types and properties of a triangle. What is a triangle? I'm saying that triangle is a regular polygon with 3 sides. Triangle is a regular polygon with 3 sides. Triangle is a regular polygon with 3 sides. Sorry. Triangle is a regular polygon with 3 sides, right? So you are saying that if I have this as my triangle, let's say triangle A, B, C. It's a regular polygon with three sides, 1, 2, 3, and it's 35. With triangles, we are saying that the sum of interior angles of triangles is what? 180. So if I add it to, let's say, x, y, and z, if I add up x plus y plus z is equal to what? 180 degrees. So the interior angles of triangles sum up to what? 180 degrees. That's for triangles. We are saying that it's a regular polygon with three sides, and the interior angles sum up to what? 180 degrees as that. Then also we can also talk about certain properties that I need to understand when it comes to triangles. Now if I extend this line a bit, extend this line a bit, and extend that line a bit, that's what is happening. Now if I know it, let's say angle P, I know it, let's say angle X, I know it, let's say angle T, that's what is happening. For me to find, let's say, angle X, one of the properties of triangle telling us that if I should add two opposite interior angles to give me what? An exterior angle. If I should add two opposite interior angles, give me what? An exterior. That's why on our learning outcome, we stated that we try and learn as much as possible the exterior theorem of a triangle, and that's what we are doing, right? So if I add up two interior angles to give me what? An exterior angle. So if I should add y plus x, it's going to give me what? This exterior angle x. Likewise, I want to get exterior angle t. If I should add x plus z to fetch me what? That's opposite, because here, where is t facing? Where they are facing is what you need to be a bit cautious of, or you need to be known. Where t is facing on this triangle, it is facing what? This side, which is what? AB. AC, AC. So AC, the angles that are within the triangle, when you add that, we're going to get what? Likewise, P here, where is it facing? It's facing what? AB. The angles within the triangle, when you add, we're going to get what? P. Likewise, X, where is it facing? It's facing what? BC. So for you to get an length, angle between what? The triangle, which is what? Y and Z, to fetch you what? X. And that's what we are talking about. So in summary, we can say that angle X is equal to y plus z. Then angle T is equal to x plus y. Where they are placed, just add the interior angle, then you get the angle for that. And you can say that angle T, where they are facing to is what? S and Z, which is what? AB, add the interior angle, then you get that angle as well. Hope that's okay, right? Then also, if you also know this angle, you can easily find this. That's angles on the straight line. Likewise, the other such things too. But if this is unknown, or let's say this is known, let's say this is known, that is known, you're going to find without this one unknown, you can use then so for x other aspect that you need to also understand. So these are the general properties of triangle for every triangle that you need to know. There are certain types of triangle that we need to also expose so that we can also know there are various individual specialized properties that they have when it comes to regular polygons and angles as well. Right. So here we have basically, I think we have three types or four types of special triangles. First, we are going to discuss what we call equilateral triangles. Equilateral triangles. So I can claim this. We are going to discuss what equilateral triangles. Right, equilateral triangles. With their properties that we need to know. So if this is my equilateral triangle, equilateral triangle. This is my equilateral triangle. We are saying that equilateral triangle have all sides to what equal, and so doing we will indicate this thing will show that they are what equal. So equilateral triangles have all sides to what equal. Good. Then also the interior angles of each equilateral triangle The interior angle of each equilateral triangle is what? 60, because they are equal. Each is having an angle of 60 degrees. Remember, we said that the interior angles of any general triangle is what? 180 degrees. So since they are having their length to what? Equal. Once you fold or rotate on each other, you clearly see that they all face and will have a wall shape once you rotate or fold them. That's why they're having an interior angle to what? 60 degrees. So you also have an interior angle to 60, their length and the size are what? Equal, right? Then also, we can say that you also have what we call 3 lines of symmetry. 3 lines of symmetry. You have 3 lines of symmetry. Also, when you say a line of symmetry in any regular polygon, we are talking about a situation where we are to fold that, we have a paper section of that figure or that shape, and we are to fold it. Each size will can fit well on each side. I mean, when you fold it like that, it can fit. So if as you fold this section, let's say as you fold it in this part, here and here can fit, then also this one can also face on this, right? That's one. Then also, so that is this that you have done. You have to fold it in this way too, you're also going to face. You also to fold it in that way too, you're going to what? First. So that's why we have that. So we are saying that equilateral triangles have all sides to be equal, interior angles of what? 60 degrees. Then also have 3 lines of what? Symmetry. Then also their rotational order, their rotational order or their rotational symmetry is also what? 3, because their size and their length, I mean, they are equal. So when you rotate it, we are saying that rotational symmetry is, I mean, rotation of a particular regular polygon, where once you rotate, you're going to have the same shape as the original shape that you have drawn here. For example, if I take this, if I should rotate it, let's say 90, 180, 270, or 360 degrees, I'm going to get the same figure or the same shape without changes in anything at all. So if I should rotate, let's say 180, I'll still get the same shape. So we are saying that their rotational order is what? I have 3 rotational order. 3 rotational order. So that is for equilateral triangles. For now, I'm just doing some rapid. I'm not going to write so that we can move on. These are the concepts that you need to understand. They are a bit easy to understand, right? Good. So that is equilateral triangle for you for now. Then also, we also have what we call isosceles triangle. Isosceles triangle. What we call isosceles triangle. We are saying that isosceles triangles is also another type of special triangle where 2 of its sides are equal and the other side is unequal to the 2. Right, so we are saying that isosceles angle, 2 of its sides are equal. Let's say A, B, and C. 2 of its sides, A, B, and AC are equal, right? Then also, since they are equal, they will have a base angle also towards equal. So if I have this angle to, let's say, A, here also go angle A, because of their length. Their lengths are 2. 2 of its lengths are equal, so their base angles also go equal. So if here is A, here is also A. So that is isosceles. 2 of its sides are equal, then 1 is unequal to the 2. We also have where the 2 sides are equal, have their base angles also towards equal, right? So we are looking at the sides and you are looking at their internal angles, right? So we can also look at their order of I mean, the lines of symmetry that isosceles also do have. On the base of that, if we are to, I mean, fold this, we are to fold this, we can clearly see that this isosceles triangle have 2 lines of symmetry, 2 lines, because two of its sides are what? No, so they have what? Two lines of what? Symmetry. How do you get what I'm trying to say? You have two lines of what? Symmetry. So if I fold it like that, sorry, I'm just talking about one hand. They have one line of what? Symmetry. Because if I to create this line, just one. Once you fold it, this line can fit, this line can also fit, then also here can also what? Fit. But if I should cause a division here, because this side is not equal to this, they cannot fit for. Some will be a bit light of a splash of, then you can't get the exact shape that they can face. So that is what isosceles triangle. They have just have one line of what? Symmetry. Then also their rotational order. The rotational order. Let's see whether they have rotational order. But we say rotational order where rotational symmetry is where once you rotate the object, at the end of the rotation, you should get the same shape as the original shape that you have. But you can see that once you rotate this, you don't get the original shape. If I should rotate this, let's say 90, here will be on this side. Well, can fit, but this side cannot fit this because they are not equal. So if one of them deviates from its place to face one another, then it becomes what? It cannot be what we call, it cannot have what we call rotational symmetry. So that's what we are talking about. Once one of its lines deviates off, not to be able to what? I mean, based on that particular in terms of the rotation, then we can say that it cannot have what a rotational order, because you won't get the same shape as you get with the original shape that we have. So it has no rotational order, has one line of symmetry, has two of its sides to be equal, and the base angles also towards equal because of the two sides. So that is isosceles triangle. So let's look at what we call scalene triangle. Scalene triangle. So you are saying that scalene triangle is also a triangle with unequal length, with unequal length, with unequal length. Scalene triangle with equal length, with unequal length. Their lengths are not what? Equal. Their lengths are not equal. So since their lengths are not equal, you clearly see that their rotational order also what? You have no rotational order. Likewise, you will have what we call line of symmetry. Line of symmetry is zero. We don't have line of symmetry. We don't have rotational order. So no rotational order, no lines of symmetry. Because they have unequal what? Lines. So they also have unequal interior angles, right? So that is for scalene triangle. So scalene, I can have this to show that they are unequal. Get what I'm trying to say? Then let's say here is A, B, yes is C. Because they have unequal angles, it's like going to be, then no rotation. Because once I rotate, it won't get the same figure that I've drawn here to be a different thing. So once it shows a different figure, then we can accept that to happen a rotational order. Then also their lines of symmetry is also doesn't exist since none of the lines are equal, because they are different size and shape forming a triangle. So that is isosceles scalene. Here is scalene, sorry. I was talking about scalene, so I hope you're getting it. Yes, I didn't erase it. Scalene. Scalene triangle. So sorry, scalene or triangle you're talking about, right? So the last part under properties and types of triangle is what we call right angle triangle. From the properties that we did right angle, right? But here it's in a triangle form section. So right angle, and so interior angle was 90, then it's like that. Right angle triangle, right? So if here, let's say here is C, sorry, let's say here is A, B, and C. So here interior angle A, B, and C. C, we are saying that this one too is also a triangle with what? Different sizes. Their sizes are not the same. They have different sides. I can use this, or I can go any way that you indicate. I'm just indicating that their sides are not the same. These are having different sides, so they're not the same, right? Then also you have their interior angles to be different, but one of its interior angles was 90. That makes it what a right angle triangle. One of its interior angles was 90. That makes it a right angle triangle, right? So we clearly see that if here is 9, then when I add up the remaining interior angles, I'm going to get 90 degrees. So we clearly see that here, you can see that angle B is equal to angle A plus what? Angle C. Because when I add up this, I'll get this. Sure, it is true. Because if here is 90, then the remaining was what we said earlier on, that triangle is having an interior angle, total interior. When you sum up interior angle of triangle, you're going to get what? 180, sorry, you're going to get 180. So if I should add up this and this, it is true that I'll get 90 degrees, right? So also going to solve the length for, let's say, AC, AB, and CD. There is this theorem called Pythagoras theorem that will help us to solve the length for this. And basically, we're doing that when we're talking about trigonometry in formal and other things. So another you'll be dealing with Pythagoras theorem. For now, we're not dealing with Pythagoras theorem, just dealing with the angles, how to find the angles. So that does not course for today's series. So that is for. So here too has no rotational symmetry, no line of symmetry. Their lines are different. Then I can say that all the sides are different. I say all interior angles also are different. So okay. So the same property as that of the scaling and other things that you need to know. So that is basically for the triangles and the type. So let's also add up that of the equilateral triangle properties and other things that you need to. Sorry, quadrilateral. Let's add up to the quadrilateral, then know how to flow. So as we have dealt with that of the properties of triangles and their types, we will end here for today. Then we'll continue with quadrilaterals and various types of quadrilaterals, polygons and those who are not polygons, in the next video, where we discuss this aspect too. Then we're doing with this, and also we'll be doing more questions in addition also for whatever we have done so far. Then we can conclude on this and take on to the next, right? So thanks for watching this video. Once again, do like, subscribe, share, comment, and make sure that you help the channel to grow so that we can be doing more videos to help you to study academically and pass your exams and other things that you need to do. Yeah, once again, subscribe can also like our Facebook page on Library Premium Educational Consult, then follow us on Instagram at Library Premium, then we can have engage with you more. Right. So thanks again for watching this video. See you in the next video where we discuss bilateral and other questions. Bye bye.